Hello everyone. In this video, we are going to discuss about process scheduling. We all know what a process is. A process is nothing but a program in execution. So whenever a process has to get executed, it needs the use of the CPU to get executed. Hence, it is the job of the CPU scheduler to assign the CPU to a particular process whenever it wants to execute. So what we are going to see in this video is we're going to discuss in detail about the queuing diagram representation of process scheduling. That is, how does a process move from the ready queue into the CPU, and under what circumstances will a process be removed from the CPU. So that is what we're going to discuss in detail in this video. Now, what you have before you is the queuing diagram representation of process scheduling. So now if you look into the diagram very carefully, we have the ready queue. Now what is meant by this ready queue? Ready queue is nothing but the queue in which all the processes that are ready for execution will be waiting. So ready queue is nothing but the area where, or the data structure which is used for holding all the processes that are ready for execution. So from the ready queue only, the process will be allotted to the CPU. So when a process is in the ready queue, the state of the process will be ready. And when the process moves into the CPU, the state of the process will become running. So from the ready queue only, any process will be assigned to the CPU. So I hope this is clear. Now, when the process is using the CPU, we know that the process will be in which state? The running state. So whenever a process is running, there is always a possibility for the process to be preempted from the CPU. The meaning of preemption is process while running can be removed from the CPU at any time. That is called as preemption. So what are the possible situations under which the process can be preempted from the CPU? A process can be preempted from the CPU. For example, whenever there is an IO request arriving. If there is a request for making use of the IO device, then the process will be immediately moved from the running state and put into the waiting state, and the process will be waiting for the IO event to complete. Once the IO event is completed, then the process will get back into the ready queue. This is one scenario. Another scenario is whenever the time slice expires. That is, the time slice expiration will be indicated in terms of an interrupt will be generated. So that interrupt will cause the process in the running state to directly move into the ready state. So whenever a time slice expires, the process from the CPU will be taken and put into the ready queue. The third scenario is whenever a process wants to create another process, that is called as forking a child. Fork a child means process creating another process. So whenever a process creates another process, in that case also, the process will be removed from the running state, and depending upon the scenario, the process that is the parent process may or may not wait for the child to complete. If it wants to wait for the child to complete, then the process will be in the waiting state. Until the child completes, it will wait, and then only the process will be put into the ready queue. And finally, the last scenario is whenever there is an interrupt that is occurring, any interrupt, right? So in that case also, the process will be removed from the CPU, and the interrupt will occur, and the interrupt will be handled by the interrupt handler, and later the process will move into the ready queue. So this diagram clearly explains that is the various situations under which a process from the CPU can be preempted. So one is whenever there is an IO request arriving, whenever a time slice expires. Then the third one is whenever a process is creating another process. And the fourth one is whenever the process is waiting for an interrupt to occur. So I hope this is very clear. The queuing diagram representation of process scheduling is clear. Thank you.